Hello everybody, we're going to be going over the Follina MSDT vulnerability, also known as CVE-2022-30190. So I'm going to be going through the TRYHACKME walkthrough. I'll be starting off with task 1 and moving through the rest of the task here. So first task is the introduction, and I'll also be reading through it as well. Microsoft explains that a remote code execution vulnerability exists when the MSDT is called using the URL protocol from a calling application such as Word. An attacker who successfully exploits this vulnerability can run arbitrary code with the privileges of the calling application. The attacker can then install programs, view, change, or delete data, or create a new account in the contexts allowed by the user's rights. Learning objectives. In this room, we will explore what Microsoft Support Diagnostic Tool is and the discovered vulnerability that it has. In the process, you'll be able to experience exploiting this vulnerability and consequently learn some techniques to detect and mitigate its exploitation in our own environments, room prerequisites, and expectation settings. There are no hard prereqs in order to gain value from this room. However, it would be helpful to have some basic understanding of various scripting tools, Windows, CLI, Linux Bash terminal, and PowerShell. Furthermore, this room will touch upon Windows processes and data correlation in lieu of threat hunting. Nothing too deep nor too complex to understand. Okay, let's go ahead and move on to task 2. Okay, the MSDT exploit is not something new. In fact, a bachelor's thesis has been published August of 2020 regarding the techniques on how to use MSDT for code execution. Almost 2 years later, after the initial publication, pieces of evidence of MSDT's exploitation, as well as code execution via Office URIs, has triggered several independent researchers to file separate reports to MSRC, the latter of which has been patched specifically in Microsoft Teams, whereas the former remains vulnerable. It's not until the discovery of nanosec, which has been made public in Twitter, that attacks using this particular vector is actively being made in the wild. This consequently picked up Kevin Belmont, who publicly identified it as a zero-day that Microsoft EDR products are failing to detect, and then later classified by Microsoft as a zero-day with the vulnerability name CVE-2022-30190. Summarized timeline of its discovery. August 1st, 2020, a bachelor thesis is published detailing how to use MSDT to execute code. March 10th, 2021, researchers report to Microsoft how to use Microsoft Office URIs to execute code using Microsoft Teams as an example. Microsoft fails to issue a CVE or inform customers, but stealthily pack it in Microsoft Teams in August 2021. They did not patch MSDT in Windows or the vector in Microsoft Office. April 12th, 2022, first report to Microsoft MSRC of exploitation in the wild via MSDT by a leader of Shadow Chasing 1, an APT hunting group. This document is in the wild, real-world exploit targeting Russia themed as a Russian job interview. April 24th, 2022, Microsoft MSRC closed the ticket saying not a security-related issue. For the record, MSDT executing with macros disabled is an issue. And here's the message. I finally had time to look at this critical. I've decided it is not a security-related issue. MSDT is indeed executed, but it requires a passcode when it starts, and the one provided in this sample does not work for me. I will be closing this ticket, but appreciate you submitting it. Regards, MSRC. May 27th, 2022. Security vendor, Nano tweet, a document uploaded from Belarus, which is also in the wild attack. May 29th, 2022, Kevin Belmont identified this was a 0-day publicly as it still works against Office 365, semi-annual channel, and on-prem Office versions, and the EDR products are failing to detect. May 31st, 2022, Microsoft classifies this as a 0-day in Microsoft Defender's vulnerability management. June 4th, 2022, a fix for this vulnerability, CVE 2022-30190, is available in June 2022's Patch Tuesday. And then we have some further reading down here. And to answer some of the questions here, what year was MSDT first discovered to be vulnerable to code execution? And that was in 2020. Who is the author of the bachelor's thesis which first detailed this vulnerability? And I had to look that one up. And that was Benjamin Alpeter. What is the name of the APT hunting group who first reported evidence of exploitation in the wild of MSDT to MSRC? And that was Shadow Chasing 1 threat hunting group. So go ahead and move on to the next task, task 3. The MSDT service. Microsoft states that Microsoft Support Diagnostic Tool collects information to send to Microsoft Support. They will then analyze this information and use it to determine the resolution to any problem that you may be experiencing on your computer. With that in mind, it's essentially a way for Microsoft Support to immediately see what's wrong as they're getting all the information they need straight from the source. Think of it like this. You're having a car problem and you don't know about cars at all. You call your trusty mechanic, but instead of him asking you to check different parts of the car while he tries to deduce what's wrong with it remotely, he just gives you a passkey, instructs you how to use it, and the car will magically produce a report that you can then send to the mechanic. Quick, easy, efficient. And we'll answer one of the questions here. What's one of the things you need that the support will provide you when you're using MSDT legitimately? And that's a passkey. Okay, we go ahead and move on to task 4, exploiting the vulnerability. Hey everybody, I'm going to be showing you how to exploit the Follina Windows vulnerability utilizing TRYHACKME's machine. We'll go ahead and start it. I'm just going to give that a second for it to load. And once it's finished loading, then I'll go ahead and click to start the attack box, which is a Kali Linux machine. At the end of this, I'll show you how to do it from your own Kali VirtualBox on your computer. But for this demo, we'll start off with the browser machines. All right, that just finished loading. We'll go ahead and start the attack box. All right, looks like it finished loading. So here's their somewhat disclosure. What we're going to do is we're going to go ahead and click enter to close it. And immediately after that, we're going to open up a terminal. We're going to then navigate over to the location of the Follina payload. So we'll go ahead and type cd /room/Follina -msdt, enter ls, and then you can see the contents of that. Also, if you want to navigate to that folder, just open up your file here, go to rooms, and then you'll see Follina MSDT, and we'll leave this open as well because we'll take a look at the Python file there. Now, it does ask us to establish a baseline. So what we can do is we can head over to the Windows machine, which in this case is a 2008 server. We're then going to click on Process Explorer, pardon the sysinternal software, open it up. Similar to Task Manager, it lists all the processes that are currently running. Looking at it, we can see that the calculator isn't running. We can see that the WinWord exe for Word isn't running. And numerous cmd.exe is running. So essentially, at the bottom, it does ask us which processes can be identified as malicious, and because they're running abnormally. So one of those would be the s-dog host.exe, the msdt.exe, the conhost.exe, and the privhost.exe. And if we look at these, we do see the con host running, but some of those other processes that I mentioned are not running. Also, we know that the win calc32 isn't running. So later on when we exploit this, you'll see those run, and you'll know that that's off of our baseline. All right, back over to the attack box. Okay, great. Let's go ahead and take a look at the Follina Python script here. Just gonna open it up, display, wait for that to load. We can see that it will create a malicious doc. It is using the Ethernet Etherface 0, and it's going to run an HTTP server on port 8000. We can also see it has a capability to do a reverse shell, which we will not be utilizing here because the Windows 2008 server doesn't have netcat on it. However, if it did, we could potentially get a reverse shell. We can see the command that will run once the Windows 2008 computer makes a connection to our malicious HTTP server, and it will execute this PowerShell command, which will tell it to open up the, we're looking down here, which will tell it to open up the calculator. This one right here would tell it to open up netcat reverse shell. And this one over here would tell it to open up the calculator, and it's coded in base 64. Go ahead and go through this lab. If you're doing this on your own computer, please wait till the end, as if you try to do it the way I'm showing you now, you will run into issues. Because the way you do it is going to have to be differently. All right. So from here, we'll just open up the command prompt from the Windows box. We'll be needing that shortly. Let's head over to the attack box. We can go ahead and close this out, as we do not need to edit the Follina Python script here. Once we have closed that out, we'll go ahead and create our malicious payload. Okay, it's very important that you open up a terminal from the location of this file. So you can see I'm in the root rooms Follina MSDT. I'm going to right click and click Open Terminal. Once a terminal is open from this file, we can then go ahead and type in the following. And you can even scroll up if you like to follow along with the commands. Python 3.9 Follina.py. Enter. As you see, it has created a malicious stock that you can see here, and it's serving the HTML payload on port 8000. With that set, next we're going to go ahead and from the Follina MSDT folder here, you're going to right click and you're going to open up a terminal. It is very important that you open up the terminal from this location, as I mentioned earlier, as we will be starting a separate Python web server. On port 3456. And next we'll go ahead and press enter. If you do not open up the terminal from this location, this will not work, as you need your web server to be at this location serving up this document here. By default, the terminal will open up from the root directory or the home directory, which is not where we want it to be opening up from. Next, let's go ahead and go over to the Windows 2008 server here. We're going to be using curl to get the file from the Kali machine. Go ahead and find out what's your IP address on the attack box. You can see your IP address here at the top. The IP address is 10.10.119.195. That's my IP address for this attack box, however, yours may be different. Okay. Okay, with that IP address entered, I'm going to go ahead and enter in the port 3456. All right, and then I'm going to go ahead and verify everything looks good. Okay, looks good. I'm going to go ahead and press enter. And we can see that the transfer is complete. I'm going to go over to the attack box to ensure that it completes successfully. This can be noted if you see a 200, meaning it was able to get the file successfully. If you see a 400, something went wrong, and you need to verify that you opened up the terminal from this exact location and to ensure that the command is spelled correctly. Furthermore, I will provide this command in details or description of this video so that you can go ahead and utilize it. Do note you'll have to change the IP address, and if you decide to use a different port, the port address as well. Okay, now from the Windows server, I'm going to go ahead and click to open up the Process Explorer. I'm going to go and scroll down to the bottom, and once scrolling down, I'm going to go ahead and open up File Explorer. Once File Explorer is open, you can click it here in your taskbar, go to this PC. You'll see the local disk Z drive. We'll click that. Click on Users and Administrators. There's the Follina Word document. The reason it's there is because by default, the command prompt will open up from this location. Therefore, any files that we download will be stored in this location. Now, I'm going to go ahead and double click it. Do know if this was a rich text document, the payload would have already initiated. However, because it's not a rich text document, we have to click on it to get it to connect back to our attack box. Immediately, you can see that the diagnostics tool has opened up and the calculator. This has indicated that the exploit has run successfully. Now, if we go to Process Explorer, you'll notice some processes here. By definition, this is considered malware because it is doing an action that we did not want it to do. Also, that it is not intended to do. Microsoft Word isn't supposed to be opening up other programs or reaching out to remote servers. Now, if this was the real world, this wouldn't be a calculator. Most likely this would be executing some type of executable on the machine or running some malicious PowerShell code to either further enumerate. Okay, so here you can see that the MSDT.exe is running. Here you can see the Win32calc.exe is running. And when we click on it and go to properties, we can see some further information here. We're going to close this out. Going to one of these questions, it's asking what was the name of the initial document that was found. Following this link, I was able to locate that. And the initial name of the file was 0522-0438doc. And it's saying what application got executed upon opening of the malicious doc that signified compromise. And that was the Win32calc.exe. Here it's saying the POC proof of concept that we use has the capability to establish a reverse shell upon exploitation. As I mentioned earlier, that would be using netcat. And if we display the Python file and scroll up here, you can see here it has some reverse shell commands, and it's specifically pointing to the nc.exe. A binary is a file that has the extension exe or bin at the end of it. Looking at the script, that is the answer, netcat. What is the binary being downloaded? We know that this binary is being downloaded from the C Windows task nc.exe, which is the answer here. You can see that it has double slash like that. That's because when you're dealing with Python scripts, you have to put the double for it to notice the path. And as I mentioned earlier, these are the processes that are running that can arise some suspicion. And those would be s.dog.host.exe for the Windows diagnostic, the msdt.exe, the conhost.exe, and the privhost.exe. As proof of concept of the zero-click implementation, because a preview host allows you to preview the files before they're actually executed or opened from File Explorer. So if I go over to File Explorer here, here's the panel right here that would allow me to preview the file, and therefore, if it was rich text, it would execute. Let's go ahead and move over to task 5. At the very end of this, after task 7, I'll go ahead and explain how you can do this on your own machine. That way you could actually download it and play with it a little bit. But for right now, let's go ahead and move on. Okay, for detection, we'll go ahead and open up full event log viewer, which if we click down here, you'll see an icon for the full event log viewer. Go ahead and open this up. Once it's open, just give it a second to load. Once loaded, you click View, use Quick Filter, and here we can type in 4688, just like they instruct. Then do Control F, invoke expressions, and here we can see that the Windows MSDT ran some malicious PowerShell script here, which uses base64 encoding. So that should be one of the answers here. And also mentions in the Python script itself that it's utilizing base64. What is the parent process of the calc.exe? Okay, to do that, what we'll do is we'll go ahead and type the following. After entering calc.exe, We can see that the creator process name is the sdog host.exe. That's the answer there. The diagnostic package index information is loaded from what file path? Okay, we'll go ahead and move over to the location, Windows, click on this PC, C drive, Windows, scroll down, you'll see the diagnostics here, and we can see an index file there. And there's your answer for that one. These are just some ways that you can detect whether or not the system has been, in fact, exploited using the MSDT vulnerability. Next, we'll go ahead and click on Task 6, Remediation. So here it says, as of June 2022, cumulative Windows update, which I believe was released on June 14th of this year. They released a patch for this vulnerability. So all you need to do is actually update the system. Do note that the update for this server takes quite a while, and they'll also show us how to disable it within the registry if you decide to go about hardening the system rather than updating it. So if you type check for updates or updates as they specify here, you'll see the Windows updates. And then below that, check for updates. We'll go ahead and click on check for updates, which brings up the settings. And here we can see that there's some updates waiting. So if we click on retry, it should begin the update process. Okay, we will not wait for the update to complete as it'll take too long. So we'll go ahead and go about deleting the registry key for this example. At this point, you can go ahead and close out the Windows Word document. And any other prompts, you can go ahead and close them out. You can close the calculator out and the troubleshooter. Okay, so once you're done with that, go ahead and enter this command here to delete the registry key. You can see the operation completed successfully. If you didn't get that, just go ahead and verify your command. After doing that, we'll go ahead and try to run the Follina Word document again by double-clicking it. And you can see it says you'll need a new app to open this MSDT. So you can go ahead and input that here, as that is a prompt you get after you have hardened the system by disabling the MSDT service from the registry. So essentially we foiled the ability for them to exploit this system. All right, let's go ahead and move on to task 7. So we learn how to transfer the MSDT file, execute it, and we now know that Microsoft has released a patch that blocks the PowerShell injection from occurring, therefore disabling the attack vector. And we also learned a few threat hunting techniques that we can utilize to determine if the system's been exploited. And also we've learned how to harden the system through the Windows updates, which is probably best if you can do it that way. All right, thank you for following along. Let me go ahead and move on to the next part of this lab, which is going to be showing you how to do this from your own host and download. At this point, what I'm going to do is I'm going to go ahead and terminate my machines and then restart them so I can go about showing you that. Okay. Do note that you have to use the Windows 2008 server they provide you in task 4, but we'll be using our own attack box. I'll go ahead and wait for that to open and get my VirtualBox ready. Okay, here I have my VirtualBox open. Next, I'm going to go ahead and initiate my OpenVPN connection. Let me just go ahead and locate the file. I'm going to open up a terminal from here. Okay, here you can see I've established my OpenVPN connection here. And I have a bash script that will establish it for me rather than having to navigate to the location of the OpenVPN file every single time and running it. I can just have this bash script do it automatically once I start it. I have a video where I'll show you how to do that, and I'll go ahead and post that in the description of the video if you're interested. Okay, the next task is to check my tunnel 0 IP. So type in if config ton 0, enter, and it looks like once I connected to TRYHACKME network, their DHCP server provided me the VPN IP address 10.9.1.21. Perfect. So now that I know my own IP address there, then what we can do next is get the MSDT Python script that we need. So as you see, I have a file here named MSDT. Taking it from the top, I'm going to go ahead and move that to the trash and create a new file. And I'm just going to name this folder MSDT. So this is a folder. And then press enter. And you can see my folder is here. After doing that, I'm going to go ahead and right click and open my terminal here. And now I'm going to go ahead and find the location of that Python script. So if I scroll through here, you'll see how they note that there's a publicly available exploit. And if I click here, it'll take me to John Hammond's GitHub. If you click here, you'll see the HTTPS link to his GitHub with the Follina.py file that we need. What I'm going to do is I'm going to go ahead and clone it. So I'm going to copy that link, go over to my machine here. Do note you want this to be stored in an MSDT folder. Otherwise, it'll be stored in your home directory, and that can get quite messy. Get clone, and then I'm going to go ahead and paste in the location of that link. And upon doing that, you can see that it's put the MSDT Follina folder here. If I click on it, you can see the file contents. Now, earlier we didn't have to edit the Python file, but we will here because otherwise earlier is using ETH0 as the outhost IP address. Outhost is our local host, which is usually the attack box, and the rhost will be the remote host, which in this case is the Windows 2008 server. So I'm gonna go ahead and open this because we're gonna have to input an IP address. If I open this, and I'm gonna close out the previous one I had. All right, there we go. And I scroll up, you'll see that by default, the interface is set to ETH0. Now, I want to change that because we'll be using our own attack box here, and we want to specify the IP address. Okay, so once I've entered in my ton0 IP address, then I'm going to go ahead and save the file. Okay, go ahead and close it out when you're done. Do note your IP address will be different, so ensure that you do the ifconfig ton0 to check which one it is. And just as we did earlier, we're going to go ahead and start a Python web server. As we mentioned earlier, you have to do it from the MSDT Follina file. So I want to do it from this directory, and so I'll just right click and open terminal here. Again, I make the mistake of accidentally opening up a terminal and forgetting that I have to open it up from the file location. So just to correct myself, I'm gonna go ahead and make sure that I open up the terminal directly from the file location. Okay, so again, that was right click, open terminal here to open it up directly from the file location. Okay, after doing that, we'll type in Python 3-m http server 3456. Okay. All right, with that said and done, we'll go ahead and move over to our Windows server. And we'll open up Process Explorer and scroll down to the bottom. All right, open up the command prompt, and then we're going to curl put in HTTP, curl HTTP // the IP address of your L host, which in this case is our own CaliBox. As we mentioned earlier, that's going to be 10.0, so that's mine right there. I'm going to go ahead and annotate that on my little notepad. All right, so after starting that web server and checking our IP address and such and editing the file, the next thing we need to do is we need to actually create that malicious document, right? And the way we're going to do that is we're going to execute this Python script here. So what I'm going to do is I'm going to right click here from the file location, ensure to do it from the file location, open terminal here. That's going to open a terminal from that direct location. And then we'll utilize Python to actually run the Python script. Python 3 Follina.py. All right, so I'm gonna press enter. And you can see it's immediately made a Follina document here. So with the Follina document there, then we can go ahead and move over to the Windows 2008 server here. And we can go ahead and try curling that document. So all you need to do is type in curl HTTP, the IP address of your machine, the port number 3456, Follina.doc, Follina.docx. So upon typing that in and pressing enter, go ahead and move over here and verify if it actually successfully got the document. And it did, because it's 200. If you see a 400, maybe a typo, maybe a wrong port, go ahead and double check that. All right, so the document's over on the server. Let's go ahead and open it up. So I'll go to this PC, local disk, and go to users, the administrator profile, and we can see the Follina document there. I'll go ahead and double click it. Here you can see that there's connections being made here. And we have the diagnostic tool opening up for the program compatibility troubleshooter, along with the calculator. And if we look here, we can see it's doing the same thing we mentioned earlier. So we're able to replicate the same thing, except using our own attack box. And now you have the Follina Python file here, so you can create your own malicious documents. Please don't use this in any illegal manner, as I am just showing you how to go about replicating it and showing you how to patch this vulnerability. A lot of this is just for situational awareness. As we are security researchers in this community, we have to ensure that people are aware of these issues and take action. So I just wanted to show you something extra. I thought it'd be fun to edit the script. So rather than opening up the calculator, we can open up something a little more scary, right? And what we're going to do is we're going to go ahead and just open up the script. The start cmd.exe is a command that you can run, and upon doing that, what it'll do is it'll start the command prompt. It'll open a new command prompt window on the victim's computer. I can tell you from experience, when people don't like when command prompts open up on their computer, they immediately think they're being hacked. Well, in this case, they are, and you can only imagine. I just opened it. Imagine what other commands I could have run. There's a lot. I could have deleted registry keys. I mean, you name it. So what we're going to go ahead and do is save it. Minimize that. We're going to go ahead and move that over here. I'm going to go ahead and stop my Python script from running. I'm going to rerun it. That way it can create a new malicious document. And upon creating a new malicious document, that will have the command that we want it to run once it's been executed. We'll then go ahead and move back over to the server. Drive here. And we'll run our curl command, which will just overwrite the Word file. If I do that, it just overwrote the Word file. If you have the Word file, go ahead and close it at this point. And I'm double click on that Word file. Okay, I just double clicked it. Do take in mind, I had to restart my Windows server, so meaning the registry key no longer applies, as this is just a brand new session here with another virtual machine. Immediately you can see that the command prompt opens up, and this is a brand new one. This is not the one I had open up earlier. And here we can see that the program compatibility troubleshooter opens up as well.